Alright, today's learning target is going to be pretty cut and dry, very simple. We're going to talk about, instead of adding polynomials together, we're going to introduce the idea of multiplying polynomials together. Now, we did a lot of this in the last unit where we were doing exponent rules and multiplying monomials. Well, now we're going to start multiplying monomials by polynomials. So let's start off by reviewing. So this takes us back to the first learning target we did, one of the first ones this semester, where we're just multiplying two monomials, right? So find each product, so we're just going to multiply these two terms together. So when we do this, we can rewrite this if you like without the parentheses if this helps you see it better. But remember, parentheses means multiply. So I'm going to multiply the 6 and the negative 4 to get negative 24. And then when I multiply these bases, I'm actually going to add the exponents together to get x to the 7th. Okay, this is just review from the exponent unit. Example B, same idea. We're going to do 5 times 7 to get 35. Then I've got x and x. Well, x times x is x squared. And then I've got y squared times y, which is y to the 3rd. Okay. So, with that said, now let's multiply a monomial times a polynomial. It's very similar, but we just have to use a distributive property when we multiply here. So if I take a look at example A, I've got this monomial right here. That's 3x, that's a monomial, and then this thing is my polynomial. So I'm multiplying a monomial by a polynomial. So to do that, I have to distribute to everything inside the parentheses. So I'm going to do 3x times 3x squared, which is 9x to the 3rd. Then 3x times 6x, which is a positive 18x squared, and then 3x times negative 5, which is negative 15x. I'm making sure my answer is in standard form, and that is my simplified product. I can't do anything else. I can't combine any like terms. Okay, let's try an example with two variables. Same idea. We just have to be a little careful. I'm going to do 2xy times 5x squared y. 2 times 5 is 10. X times x squared is x to the 3rd, and y times y is y squared. Then I'll do the next one. 2 times 3 is 6, x times x is x squared, and y times y squared is y to the 3rd. And then finally, the last term, 2 times 7 is 14, x times x is x squared, and y times y is y squared. I'm checking that it's in standard form. It is. So that's my final answer. So why don't you just take a second, pause the video, and try to do the your turn example. So pause, take about 20 seconds, and try that problem. This should be your final answer. If you don't have these terms, then you've probably added combined like terms or multiplied incorrectly. If you have these terms but didn't put them in the right order, this is in standard form. Remember, every time we write a polynomial, you have to check to make sure it's in standard form, meaning alpha order by decreasing degree. Okay, so it's always something we need to be checking for going forward. Okay. There's another way to think about multiplying polynomials, and we're going to get into this a lot more later. I'm going to introduce it now because it's a really awesome way to help organize our work, and it's called area modeling. So area modeling is used to multiply polynomials to help organize our work. Multiplying and finding area go hand in hand, because to find area you multiply. So if I look at this first box, area is length times width. I'm multiplying this side by this side to get LW, right? L times W is LW. So similarly, when I'm multiplying polynomials, I'm kind of in a weird way finding area because I'm multiplying one thing by another. Okay, so in this next box, I've got p times 10. I could write that as p times 10, right? That's another way to write in algebra what this box is representing. In the next box, I now have like one big box and two little ones. Well, to find the area of this whole shape, I'm really going to do the inside, which is 6 times 10, plus the area of this little one, which is 3 times 6. Okay? So, which is the same thing. 6 times 10 and 3 plus 6 is 60 and 18, which gives me 78. Okay, I broke it up into little pieces and then added them together. But if I look at the top and the side, I've got this guy right here, which is really the same thing as 10 plus 3. That's the total length is 13, and this is 6. So it's the same thing as saying 13 times 6, which is also 78. So we can think of area in two ways. We can think of it as the inside added together, but we can also think of it as the outside multiplied together. So one way we can help organize our work in terms of algebra is instead of distributing this problem in example 1, I can draw a little area model. Okay, I'm really trying to find the area of x and x plus 4, right? I'm multiplying x times x plus 4, but let's break that into two little mini squares and do them individually. So I have x times x to give me x squared, and 4 times x to give me 4x. And then to find my total area, I just add them together, like this, and that's my new expression. Now notice, I would have gotten this answer if I had just also distributed, right? X times x is x squared, and x times 4 is 4x. So you're probably thinking, why would I do this? Why would I draw this box and I can just distribute? Well, when we get to more complicated polynomials, you might find that this is much easier to limit mistakes. And then we get into the next learning target, when we start getting into bigger polynomials, this is going to be a much easier way to do it. So I'm introducing the concept now in case you do like it and want to use it now. Okay, I'll do another example. This is a monomial times a trinomial. So when I draw my area model, let me draw that a little lower here. When I draw my area model, I'm going to have the 3m squared minus m minus 7 on one side to represent my length, and the 5m to the third represent my width, because I'm multiplying them. And then I can just break those into little mini areas, and then do each one individually. This becomes 15m to the fifth, this becomes negative 5m to the fourth, and this becomes negative 35m to the third. I can see none of these are alike, so I'll just rewrite it in standard form, and that's my final answer. So it's just one way to help organize your work, really. It's one way that I think is a great way to limit mistakes. Okay, I'd like you to pause and try and do this with the area modeling with these two problems. So draw the area model that you need and multiply the way I did in the other two examples. So go ahead and take maybe 1 or 2 minutes to multiply using the area model. So these are what your area models should look like and your final answers should look like. I think it's a good strategy to use. I'm not going to force you to use it in this learning target, but it is something to think about going forward. Okay. The last thing I want to talk about is combining multiplying monomials into also having to combine like terms. So sometimes you have to distribute and multiply twice. So in this example, I've seen 2 parentheses, so I'm going to have to distribute those before I do anything else. So I've got 3x minus 15x squared, and then negative 8x squared plus 32x. And we've done this before early when we were solving equations. I'm just bringing it back up so we can practice using exponent rules. So these two are like terms, so I end up getting negative 23x squared, and then 32x and 3x give me plus 35x. Okay, so very short and sweet learning target. The practice might take you a little bit of time. I put a lot of problems on there. Be careful with your variables, and good luck.